In this lesson, we're going to be talking about the maximum and minimum value of a quadratic function. Sometimes you don't have to graph the entire function in order to figure out what the maximum or minimum value is. We can just identify it based on what the vertex is. So first we're given a function g of x equals 3x squared minus 6x plus 1, and we want to determine whether the function has a maximum or a minimum value. So remember, this is going back to our value of a, and if a is greater than 0, the parabola will be facing upward, so it would have a minimum. If a is less than 0, the parabola will be facing downward, so it would have a maximum. So in this example, we have that a is equal to 3, because remember, this is of your form ax squared plus bx plus c. So a is the number in front of x squared, the coefficient, so that way we have a equals 3. So since 3 is greater than 0, that means that the graph is facing upward, which means that the vertex would be a minimum, which means that there would be a minimum value. So then for part B, we want to actually find what that minimum value is, and we want to determine where it occurs. So the important piece here is that whenever we see that word value, it's always talking about the y-coordinate. Okay? It doesn't want the x. The x would be where it occurs, but whenever it says the actual value, it wants the y-coordinate or the function value. So in order to find this value, we need to find that vertex and use our vertex formula. Well, remember that vertex formula is negative b over 2a, comma, f of negative b over 2a. So again, when we're talking about the value, we're really talking about that f of negative b over 2a. But in order to find that, we need to find the x-coordinate first. So looking back at our g of x function, we already found that a was equal to 3, and we see that b would then be equal to negative 6. So applying this formula, we're first going to find the x-coordinate of your vertex first, which would be x equals negative b over 2a, which would be negative 6, or the opposite of negative 6, over 2 times a, so 2 times 3. Well, in the numerator, that means we're going to have 6 over 2 times 3 in the denominator is 6. 6 divided by 6 is 1. So to start with, we have an x equals 1, which would be your x-coordinate of your vertex. But again, in order to find that function value, we need to substitute that back into our g of x function. So though, again, remember, this is the general form with the f of negative b over 2a, same thing as doing g of negative b over 2a, which really just means that we need to find g of 1. So substituting that in, we're going to have 3 times 1 squared minus 6 times 1 plus 1. So working through that, 1 squared is 1, so we would have 3 times 1 minus 6 times 1 is 6 plus 1. So we have 3 minus 6 plus 1. So 3 minus 6 would be a negative 3. Negative 3 plus 1 would be negative 2. So when we write our answer, we're going to say that we have a minimum value, right? It's a minimum because going back to what we said in part A, excuse me, we had that minimum value of negative 2. That would be the minimum value. And where it occurs would be at that x-coordinate, x equals 1. So we would say that there's a minimum value of negative 2 at x equals 1. Now that we've found that minimum value, we can also identify the function's domain and range without having to graph it. Again, like we were talking about before, is that your domain is always going to be negative infinity to positive infinity. Any polynomials that you have, we don't have any restrictions in terms of the values we're allowed to plug into the function. But then our range is going to depend on what we just found for our minimum value. So remember, we had a minimum because we had a was greater than 0, which meant that the graph was facing upward. And if we have a minimum, that means for our range that we're going to have some number, comma, infinity. The contrast to that is that if we had a is less than 0, that would mean that we would have a maximum. And we would be going from negative infinity to some number because the graph's facing downward. So here, we're dealing with the minimum. So we're going to have an answer that's of the form some number comma infinity. Well, remember that number that happens down here, like we saw when we were graphing, is that it just ends up being that y coordinate of our vertex, or that minimum value, which we just found in part B. When we find that minimum value, we said that it was -2. So that means that our range is from -2 to infinity. Again, since the graph is facing upward. You can verify this by graphing the function as well, so that we would have our minimum value, our lowest y value be -2, and the graph goes all the way up to infinity.